Assalamualaikum, my name is Muhammad Hilmi bin Shamsuri. My metric number is B1125-10740. Today I want to describe what is the transfer function. Transfer function represent about the relationship between the input and output. As we can see here, is defined as the ratio of the output signal y omega to the input signal x omega. Y omega is angular frequency. This is the equation, ratio between the y omega and x omega. Transfer function actually are widely used in electrical and control system to analyze how circuit respond to different frequency, making them essential for designing filters, amplifiers and other signal processing system. I want to explain about how to get general equation from the transfer equation. First, from the equation given, we factorize 5 and 20 from the first bracket and second bracket. Okay, after we factorize both brackets, we need to substitute to the equation. After the substitution, we need to multiply the constant there, which is 5 and 400, to complete the equation. After that, we need to find gain k. So how to find the gain k? First, we need to take 300 divide by 2000 and we get 7.15. So we substitute the gain k to the equation, then we get the final general equation answer.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Darwish and I will be explaining on how to solve the magnitude mode plot for question A. First of all, we need to use the standard equation that we have found, and then we have to use the general equation, which is 20 log base 10 ABC, and then we have to substitute all of this into the general equation, which will be 20 log 0.15 plus 20 log omega minus 20 log 1 plus j omega over 5 and minus 20 log 1 plus j omega over 20 squared. The first one, we have to plot the logs that we have got, and the first one that we got is 20 log 0.15. If we put it in a calculator, we will get an exact value because it is an constant, and we have to put the value here on y-axis, and since it's an constant, it will be just a straight line, or we call it zero pole. So the next one is 20 log omega, which will intercept at 1, as we can see here on the x-axis. It will intercept at 1 and goes up to 10 here at 20 decibels. And the next one is 20 log 1 plus j omega over 5, which we will know it is negative in the equation that we made, so it will go from 0 straight to 5 here, down here, and will go down to 20 decibels, negative 20 decibels. And finally, we have our last logs, which is 20 log 1 plus j omega over 20, which is same as the green one, which will start from 0 or origin point to 20 on the board plot and goes down. It will drop to negative 40 decibels. After making all of our plots, we have to combine of all our line and make a line here, which is the black line, as you can see here. First plot is going up, which is plus 20 decibels. It will go up, and then when it goes to 5, you will meet this one here, which is negative 20 and positive 20, which adds up to 0. That's why it's flat here. And then, so at x-axis 20, we will have a slope that will be going down, and for the solid line, it will go down -40, because if you remember, in our original equation we have squared, so we have to bring the square in front to 20 and it will become 40. In this equation it will be -40 from our equation, so the last line will go down to as -40 decibels.
My name is Muhammad Zaim Zafran bin Muhammad Zain. My metric number is B11251078 So today I'm gonna explain how to plot phase both plot in the semi-log graph. Okay, first of all, I redo calculation from my friend just to get to make it easier for me to do transfer it to phase. So after I got the answer, from 0125 j omega become 90 degrees because it's constant, and then we got negative tangent inverse omega over 5 from this, and then we got minus 2 tangent inverse omega over 20 from this. Okay, move to the boot plot. First of all, we find the first answer, that is 90 degrees. So I do a straight line here, the constant one. Okay, the second is we find a point 2 for minus tangent inverse omega over 5. Okay, this one between 0.5, from 0.5 until this 200 in minus 135 degrees. Okay, for the third line, we start from 2 and with 20 at minus 135 also. Okay, and then I do the final answer, start from 0.2 until 0.5, do a flat line at 90 degrees. Then we jump down here from 0.5 to 2 at 45 degrees, and then we jump straight here from 2 until 20 at minus 135 degrees. Then from 20 we go to 200 at minus 180 degrees, and then we just go straight line, flat line at minus 180 degrees at 1000. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Danish Iman bin Muhammad Hafiz from BLT S12. My metric number is B1125107050. I want to determine the transfer function from the both plot. Step 1, we determine the gain constant K at omega equals to 1 radian per second. The magnitude is 0 decibel. So we take equation 20 log base 10, okay, multiply by 1 equals to 0. So after that we get K equals to 1. We need to find the first corner frequency at omega equals to 10 radian per second. The slope change from positive 20 decibel per decade to 0 decibel per decade. The change in slope is this equation. So we get a negative 20 decibel per decade. So from this question we can get a decrease of 20 decibel per decade indicate the presence of a pole at omega p equals to 10 radian. So the equation is 1 plus S per 10. Next, we need to find omega equals to 50 radian per second. The slope changed from 0 decibel per decade to negative 20 decibel per decade. So the equation is negative 20 substitution 0 equal to negative 20 decibel per decade. So we get so this is a omega equals to 50. The equation is 1 plus S per 50. After we got all the equation, we can put the equation to general equation. This is the general equation, but this is not the final answer. The final answer is we want the transfer function. So we change this general equation to transfer function. We can change using a formula. So the final answer for the equation is 500S per S plus 10 multiply S plus 50. That's all from me. Thank you. Today I want to tell about completion for this assignment. Through the completion of this group assignment, we have gained a comprehensive understanding of frequency response analysis in linear network by particularly applying transfer function and their corresponding bootstrap. Specifically by tackling the assigned question. We learn how to systematically extract state equation from a given transfer function to identify corner frequencies, poles, and zeros, allowing us to accurately sketch both magnitude and phase plot on similar graph paper. Conversely, we also develop the reverse engineering skill required to derive a transfer function directly from a provide magnitude board plot by analyzing its initial gain, corner frequency, and slope variation, such as positive 20 decibel per decade or negative 40 decibel per decade. Beyond the technical circuit analysis, this project significantly enhanced our collaborative and communication skill, challenging us to distribute tasks effectively among our team members and articulate our mathematical finding clearly through a structured video presentation. That's all from me. Thank you.